Welcome to NUCLEII online classes. Already we have discussed about quadratic polynomial in part 1 video. Now here some more problems based on quadratic polynomial. Now here the question, find the zeros of the quadratic polynomial f of x is equal to 4x square plus 3x minus 1. Hence write a polynomial whose zeros are reciprocal of the zeros of the polynomial f of x. So there are two questions in this. Find the zeros of quadratic polynomial. So let us find that one. F of x is equal to 4x square plus 3x minus 1. 4x square. So here in place of 3x you can take as 4x minus x, because your product is 4 into minus 1 minus 4. So minus 4 we should get. Minus 1 as it is. 4x take out from these two terms, x plus 1 will be there, and from this minus 1 take out, x plus 1 will be there. Now x plus 1 is one factor and another factor 4x minus 1. Now here what are the x values? X plus 1 is a factor, so x value minus 1. Here 4x minus 1 is a factor, so 1 by 4. So these two are the zeros of this quadratic polynomial. Next, hence write a polynomial whose zeros are reciprocal of the zeros of the polynomial. So here whatever zeros are there, reciprocal we have to take. So what are the reciprocal of minus 1? Minus 1. Reciprocal of 1 by 4? 4 by 1. So these two are the reciprocal of these two zeros. So using these zeros we need to write polynomial, quadratic polynomial. Okay. So x square minus sum of zeros, minus 1 plus 4 by 1, nothing but 4, into x plus product of zeros, minus 1 into 4. So x square, 4 minus 1, 3 into minus 3x, minus 1 into 4, minus 4. So this is the required polynomial. Okay. Next, one more question. Say the number of polynomials having minus 2 and 5 as zeros is. So here any quadratic polynomial is having two zeros, here minus 2 and 5. But their question is the number of polynomials. How many polynomials you can write using these two zeros? So alpha is equal to minus 2, beta is equal to 5. So let us write one quadratic polynomial. X square minus alpha plus beta into x plus alpha into beta. X square minus alpha plus beta, minus 2 plus 5 into x plus alpha into beta, minus 2 into 5. X square, 5 minus 2 is 3 into minus 3x, here minus 2 into 5, 10. So here we have written one quadratic polynomial. Still, how many quadratic polynomials we can write? If you multiply this complete polynomial with the 2, for example, if you multiply with the 2, what you will get? 2x square minus 6x minus 20. This is also required polynomial only. If you find out zeros for this, you will get minus 2 and 5. If you multiply with 3, 3x square minus 9x minus 30. This is also quadratic polynomial. Zeros you will get minus 2 and 5 only. So here we can write infinite number of polynomials using any two zeros, alpha and beta. Using that we can write infinite number of polynomials. Okay, so this answer is infinite. We can write infinite number of polynomials. Okay. Next, See, there is one more question. If the product of the zeros of quadratic polynomial 3x square plus 5x plus k is minus 2 by 3, find the value of k. Here already they have given the product of zeros. So product of zeros nothing but alpha into beta. That is we know c by a. Okay. So alpha into beta minus 2 by 3 in the question itself they have given is equal to c by a. C is nothing but here constant k by a is nothing but coefficient of x square 3. Okay. So 3 gets cancelled. K is equal to minus 2. Okay. Next. See here one more question. If alpha and beta are the zeros of the polynomial f of x, p x square minus 2x plus 3p, and alpha plus beta equal to alpha into beta, this condition is there in the question, then find the value of p. Now alpha plus beta is equal to alpha into beta. We know alpha plus beta nothing but minus b by a, alpha into beta nothing but c by a. So here a gets cancelled, minus b equal to c. Substitute the value minus b is nothing but x coefficient minus 2. So minus into b value minus 2 is equal to c 3p. Okay. Now 2 is equal to 3p, then p is equal to 2 by 3. So this is one type of question based on quadratic polynomial. Okay. Next. See here, if alpha and beta are the zeros of the polynomial f of x is equal to 4x square plus 3x plus 7. So there is a polynomial, quadratic polynomial, and alpha and beta are the zeros. If the question is, then 1 by alpha plus 1 by beta is equal to, so we need to find out 1 by alpha plus 1 by beta. So this, if you can take product as LCM alpha into beta, so numerator you can get alpha plus beta. Alpha plus beta minus b by a by alpha into beta c by a gets cancelled, minus b by c. So direct you can take 1 by alpha plus 1 by beta is equal to minus b by c. Minus b is nothing but 3 by c value 7. Minus 3 by 7. Okay. Next. See here there is a problem. If alpha and beta are the zeros of the polynomial f of x is equal to x square plus px plus q, then a polynomial having 1 by alpha and 1 by beta or its zeros is. So this is a given quadratic polynomial. Now, so to find a quadratic polynomial, there is one condition, x square, x is the variable I am taking here, minus sum of zeros into x plus product of zeros. So here what are the zeros? 1 by alpha and 1 by beta. So x square minus 1 by alpha plus 1 by beta into x plus 1 by alpha into 1 by beta. Now 1 by alpha plus 1 by beta. See here, 1 by alpha plus 1 by beta you can write as alpha plus beta by alpha into beta. Alpha plus beta is nothing but minus b by a divided by alpha into beta is c by a gets cancelled, minus b by c will be there. So in place of 1 by alpha plus 1 by beta you can take as minus b by c into x plus 1 by alpha into 1 by beta. So 1 by alpha into beta. We know alpha into beta is c by a. So 1 by alpha into beta is a by c. Okay. Next, you can substitute here x square minus into minus it will be plus b by c p by q into x plus a by c 1 by q. Now here there is denominator q, cancel that, q x square plus px plus 1. So this is the required answer. Okay. Next, here there is one more question. If 1 0 of quadratic polynomial k plus 1 into x square minus 5x plus 2k is reciprocal of the other, find k. 1 0 is reciprocal of other means alpha into beta is equal to 1. 1 is, suppose alpha is x, beta is reciprocal of x means it becomes 1 by x. So what is the product x into 1 by x? Nothing but 1. Okay. So like that we can take this condition alpha into beta is equal to 1. When we can take this condition 1 0 should be reciprocal of other. Now we know the condition c by a, alpha into beta is equal to c by a, that is 1. So c equal to a. Okay. Now here take the word c value 2k constant is equal to a, x square coefficient k plus 1. 2k minus k is equal to 1, then k is equal to 1, k value 1. Okay. Next, say one more question. Find the value of k such that the polynomial x square minus k plus 6 into x plus 2 into 2k minus 1. Find the value of k. Sum of its zeros equal to half of their product. So sum of its zeros alpha plus beta is equal to half of their product. Okay. Sum of zeros nothing but minus b by a equal to 1 by 2 into product c by a. A gets cancelled. Minus b equal to c by 2. Minus 2b equal to c. Now substitute minus 2 into b value nothing but x coefficient minus into k plus 6. So you can take minus k minus 6, minus k minus 6 equal to c 2 into 2k plus 1. So 4k minus 2. 2 into 2k 4k, 2 into minus 1 minus 2. Simplify it. Minus 2 into minus k 2k minus 2 into minus 6 plus 12 equal to 4k minus 2. 2k minus 4k equal to minus 2 minus 12. Minus 2k is equal to minus 14, then k equal to 7. Okay. So these are the questions about quadratic polynomial. Next, topic is graphical representation of quadratic polynomial. See, any quadratic polynomial, if you take, you will get the graph like this or like this. We can call it parabola. The graph of quadratic polynomial is nothing but parabola. Okay. Now, here there is x-axis and y-axis. X negative, here y negative. 1, 2, 3, 4. Here minus 1, minus 2, minus 3. Here 1, 2, 3, minus 1, minus 2. Suppose graph, if you draw the graph, like this, one parabola came. This is also one quadratic polynomial, nothing but parabola. Y is equal to p of x, means in the quadratic polynomial the variable is x. So here this parabola is intersecting the x-axis at 2 points. See, here 1 point and here 1 point. So here what is the x coordinate? Minus 1. Here what is the x coordinate? Plus 1. So zeros or solutions of this parabola of this quadratic polynomial are minus 1 and plus 1. So without doing factorization method or completing square method or quadratic formula method, direct through the graph we can get minus 1 and plus 1. These are the zeros of quadratic polynomial or parabola. Suppose like this, one parabola came after drawing the graph. See, it is intersecting the x-axis at only 1 point, right? For example, this point is minus 2, here minus 1. So quadratic polynomial has 2 zeros, but here we got only 1 zero, that is minus 2. So if graph comes like this, both zeros are same, that is minus 2 and minus 2. 2 zeros are equal, minus 2 and one more zero also minus 2 only. So x values minus 2 and minus 2. Okay, this is also graph of y polynomial in the variable x. Sometimes it may also come. Next, here some questions may come like this. One polynomial ax square plus bx plus c. One quadratic polynomial is there. So I have drawn like this. So it is intersecting at this point on the x-axis and intersecting at this point on the x-axis. So 2 zeros will be there. Now the question is, what about A, what about B and what about C? Means whether positive or negative or equal to 0. Whether positive or negative or 0. How can we check? Through the graph. See, first let us check A. Whenever the graph opened upwards, the parabola or curve opens upwards, A is always positive. A is always positive. When it opens downwards like this, when it's opened downwards, here A value is negative. Okay, so A value completed. Positive, open upwards positive, open downwards negative. Next, B, let us wait some time. C value. Here, the parabola is intersecting the y-axis, here. So here y value is negative. So C also negative. So how it is possible? Here ax square plus bx plus, here the quadratic polynomial ax square plus bx plus c, this equal to y you can take. Here this curve is intersecting the y-axis, means what? X will be 0, x coordinate is 0. So this term you will get 0 and this term you will get 0. Finally y is equal to c. So here y coordinate is negative, so c also negative. Suppose this curve intersect the y-axis in the positive direction, then you can take y, c is positive. Say like this. In this curve, the parabola is intersecting the y-axis in positive direction. This is positive direction, right? So here c is positive because y is positive, y equal to c. Here it is intersecting in negative direction, so c value negative. Next, sometimes through the origin it may go, through the origin. That time also you have to take c is positive. Next, so C completed, A completed. How to check B? Here, one parabola I have drawn. This is y is equal to polynomial in the variable x. See, this curve came like this, and here some one maximum point will be there and it returned. Okay, so this maximum point, how to find this maximum point? That you can represent with P, letter P. So here x coordinate is minus b by 2a and y coordinate is d by minus 4a. These are the coordinates. Here a, b, you know very well, a is x square coefficient, b is x coefficient. Here d is nothing but discriminant. So d is discriminant. We can find out b square minus 4ac. So discriminant is b square minus 4ac. So minus b by 2a is x coordinate, d by minus 4a is the y coordinate. Now if you take here x in this maximum point in this curve, this is first quadrant, this is second quadrant, this is third quadrant, this is fourth quadrant. So in third quadrant x is negative, no? So here minus b by 2a is negative. Minus b by 2a x coordinate is negative, means less than 0 in third quadrant. So minus b is less than 0 from this condition. If minus b is less than 0, b is greater than 0. Okay. So how to check b whether positive or negative? You have to take the maximum point in that what is x coordinate and it is there in which quadrant. Sometimes in second quadrant you may get. In second quadrant if it comes, in that situation also we have to take x minus b by 2a is negative. Suppose like this one parabola is there. So here maximum point P is in fourth quadrant. So in fourth quadrant x is positive direction. So minus b by 2a x coordinate minus b by 2a, fourth quadrant x is positive, no, greater than 0. So minus b is greater than 0. Then b you can say less than 0. Okay. Here when this condition is possible, curve is open upward, that's why a we have taken here positive. Suppose curve is in downwards, a you have to take negative here. See, one graph I have drawn like this. The maximum point, for example this one, maximum point. So here the coordinates minus b by 2a and y coordinate is minus d by 4a. Now here curve is open downwards, so a value negative, minus b by 2a, it is in second quadrant. So in second quadrant x coordinate is positive, so greater than 0, minus b by 2a. See here a is negative because curve is open downwards. So if a is negative, here minus gets cancelled, b by 2a greater than 0. Okay, so b is greater than 0, like that. So first we have to check the graph whether open upwards or open downwards, depends on that a value we have to take. Then minus b by 2a whether greater than 0 or less than 0, that according to quadrant, whether it is in first quadrant or second or third or fourth, we have to observe and we have to take whether greater than 0 or less than 0. Okay, now one question. Like this one curve is there, parabola, the maximum point here P. Now options, a is greater than 0, b is less than 0, c is greater than 0, like that 4 options will be there. Here first it is open downwards, so a is less than 0, finish it. And the curve is intersecting the y-axis in the positive direction, so c is greater than 0. These two completed. Next, maximum value, maximum point is in second quadrant, so minus b by 2a is less than 0 because second quadrant x coordinate is negative, and here it is opened curve, so a also negative, here minus cancel, b by 2a is less than 0, then b is less than 0. So this is the answer. Clear? So this is a graphical representation of parabola. In the examination sometimes they may ask like this: x, y, x negative, here y negative, like this one curve they can give. Here y is equal to p of x, so the polynomial in the variable x, so the curve is intersecting on the x-axis, here it is intersecting and here it is intersecting, so total 3 zeros are there for this curve or for this polynomial. The number of zeros 3, 1, 2, 3. Okay, so like this also they may ask, or like this also they may ask. This is about quadratic polynomial parabola. Okay, next still some more questions we will discuss in next class. Thank you.